Everything is being done.
Starting with the name of Allah, who is the creator of this whole universe. Assalamu alaikum and good morning to all of you. Ladies and gentlemen, I would like to welcome you all to another module of SolidWorks Bootcamp. This is your host of the day, 𝐒𝐿 Muzaffar, General Member Team Communication, 𝐈𝐼MechE TAxila Student Chapter. Permit me to start the session with the holy name of Allah Almighty.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم اقرأ باسم ربك الذي خلق خلق الإنسان من علق اقرأ وربك الأكرم الذي علم بالقلم علم الإنسان ما لم يعلم كلا إن الإنسان ليطغى أن رآه استغنى إن إلى ربك الرجعى.
Jazakallah. The Institution of Mechanical Engineers is an independent professional association that represents mechanical engineers and the engineering profession worldwide. IMechE was founded in 1847 and is headquartered in London, UK. The institution has over 120,000 members in 140 different countries. IMechE is committed to promote the development and sharing of engineering knowledge and advocating the importance of engineering to society. SolidWorks Bootcamp is a training program designed with objective of providing hands-on experience and practical knowledge of SolidWorks, a popular 3D modeling software used in various engineering and design applications. It also aims to provide tools and how to use them effectively in real-world applications, which would result in enhancing the problem-solving and critical thinking skills of participants, as well as their ability to work in team and communicate effectively. As we all know, that SolidWorks Bootcamp is divided into several modules, each of which focuses on a specific aspect of SolidWorks. So today's session of SolidWorks Bootcamp will be about the introduction of assembly from basic to advanced level. Overall, the SolidWorks Bootcamp module provide a comprehensive training program for those interested in learning SolidWorks from basics to more advanced techniques and applications. Now I'll be handing over the stage to our honorable speaker for today's session, Ammad Ejaz, for further insight regarding today's workshop.
Assalamu alaikum, ladies and gentlemen. Welcome to the third session of SolidWorks Bootcamp. In this session, we will learn about basics of SolidWorks assembly and how it works and how we can import different parts and combine them to form a machine or assembly. First of all, we will go through the queries of previous session. Recently, uh, in the previous session, we received a couple of queries. One of them was, what's the difference between AutoCAD and SolidWorks? AutoCAD and SolidWorks both are design softwares that are used for the uh, CAD works. But the main difference between CAD and SolidWorks is that AutoCAD is a destructive process. Anything you make in AutoCAD is a destructive process. Like if you have drawn a line of about 25 millimeters, you can't change it. It's a dimension. If you want to extend it, you will have to make another line of about of your respective line. If you want to change this dimension to reduce it, you will need to trim it. On the other hand, in SolidWorks, you can change any dimension or any feature at any time. Also, SolidWorks provide other features like SolidWorks simulations and assemblies. In AutoCAD, you can't do the assemblies it's just like in SolidWorks. You don't have options of mate and other features. The other question was, what is? Let's go to the part file. The other question was, what's boundary boss space feature? Uh, in the last session, I skipped this feature because it's just like lofted boss space, but with some other features. For the illustration of this feature, let's go to the top plane, start a new sketch. Let's draw a simple geometry. For the ground plane, I will choose a center rectangle and draw a random rectangle of about this dimension. Exit this sketch, go to the view orientations, and select isometric view for the better illustration. Now, in order to we need another plane that is parallel to this plane. For that purpose, let's go to the reference geometry, select plane. Now it is asking for the first reference. For this first reference, we will select top plane. Currently, it is set to offset. We can change it to angle, coincident, parallel, or perpendicular. We need an offset of about, let's say, I need an offset of 5 inches. With my cursor, you can see a mouse button with the right click arrow. You can select it or go to the left side and select it OK. Now we have created two planes. To fit the geometry, on your screen, just select zoom to fit. Select the top plane, select the plane we just created, and start a new sketch. To make this plane parallel to our screen, go to the view orientation and select normal tool. Create a new sketch. Let's say I want to go with a polygon of 6 sides. Select the center point and draw its radius. Now we have two geometries. Exit this sketch, go to the view orientations and select isometric view. Go to the boundary boss space feature and select both geometries. We have selected one geometry and the second one. You can see we are creating the same feature just like lofted boss space. Now, the point to be noticed here over here, we got another point which is a green point. This point is showing that the direction of our geometry. Like this point of our rectangle will be merging with this point of our polygon. I want this point to be merging with this point. So just change this direction and geometry will be updated respectively. Other than that, we have other features like we can make this feature tangent, direction vector, and other features. Let's select this feature. Selecting this feature, we have created first plane normal to. We have created this geometry normal to our second sketch. To increase this sketch tangent length, we can increase this length or change its direction respectively. These are some extra features that are not available in lofted boss space. That was the key difference between both features. Coming to the today's session, Let's release this feature, or you can minimize it for later use. Go to the new file. Now we so far we have worked on part files. We have learned how to create sketches and how to convert these sketches into part file, into 3D objects. Now in this session will be working on assembly files. What this assembly file feature icon means, you can merge more than one part to create an assembly. Just select this assembly and hit OK. On starting assembly, you can see a pop-up on your screen. This pop-up is asking us to insert files. You can cancel it or insert the file you want. Let's cancel this feature, and let's visit the user interface of this assembly feature. On the top, you have command bar, just like before in the part files. We have added a component feature. You can edit a component within an assembly. For the assembly feature, you can insert multiple components. Other than that, we have mates. What are mates? Mates are just like relations. As we have studied in our part files, that mates are that relations are define the relation between two components. Similarly, in 3D objects, we have mates. For other features, we will visit other features. Let's start assembly. Let's click insert component, and then you have provided this file to you. If you go to the WhatsApp group, we have provided a file, that is zip file. If you extract it, we have two folders in it, 1 and 2. Let's go to first file and select base. Select the base and select open. Now you can see my cursor is holding the object. If I want to fix this object on the plane, just select OK. Now we have successfully imported one component. Okay. If you go to the features, you can see all the hierarchy of the object are visible over here. If you want to edit some features of it, you can just click on it and edit part. For the editing feature of this inside an assembly feature, you need to save it. Let's save it. Let's save it on our on your favorite directory. Let's call it assembly1. Now it's asking that your part file is older version file. If you want to save it, and it will not be able to be open on previous version. Let's go with save. Now you can see we are inside of editing feature. We can change any sketch. We can change any features. This is just like an part file. You can see all the features on your drive. Let's exit this sketch. This is edit component feature. Go to the view orientation and select isometric. Now we have one part, but we need other parts for the assembly feature. Go to the insert components, and here you can see the preview of our other components. To make these icons bigger, just go to the right side and select large icon or extra large icons. Now we have successfully created imported this component, base component. We want this second component, that is bracket. Just select this component and hit open. You can see my cursor is holding the second component. Just click anywhere and the component will be imported over here. Now this component is movable, but this component is fixed. When you are working in assembly, SolidWorks identifies the first component as the main component or the parent component and makes this component as a fixed component. You can move this component by hitting right click and selecting float. Also, similarly, you can, as you can see, this component is floating right now, and you can move it. If you want to fix it, just click right click and then fix it. Okay. We want this component to be sitting on this part over here. For that purpose, let's select this plane, this face, and rotate it. Rotate it, as you can see, So you can see the bottom part of this second component. Select both components. As you can see, we have a pop-up over here. It is asking us to define some constraints. Just like relations in sketches, we have mates in assemblies. What this first component will do, it is called a coincident relation. Second is parallel, third is perpendicular, and the fourth is log components. These are the primary component. These are the primary mates, and the other are advanced features. You can also access this bar from this component, from this option. Just select mate and select respective components, respective faces. As you can see, our component has is automatically dragged to this respective position. If you want to change its orientation, you can flip it from here. Currently, we don't need to flip it, and just select OK. Now we need to rotate this component about this plane. You can just simply select this feature, this face, rotate it, so you can see this side of the bracket. Select both of these faces and select coincident. Now you can see it is currently making these components coincident. But what I want, this bracket, this part should be facing in this direction. For that purpose, go to the mates. In your feature manager, under your assembly file, you can see the mates that we have already created. The first one was coincident and second was coincident. If you want to flip it, just go to the edit feature and select mate alignment. Hit OK. Next, we want this face to be coincident with this face. Select first face and then select second face. As you can see, our both components are perfectly aligned with each other. What we want now, we want this plane, this part to be mirrored over this side. We can copy this component and do the same steps again and again. But there's a smart feature for that is called mirror feature. In order to copy a component, you can select insert component and add another component. Other than that, you can just hold your control key on your keyboard and drag a component. You will get another copy of the component. For this operation, we are going to mirror this component. Just select the component and hit the lane. Go to the linear component pattern. When selecting the drop down, you can see mirror components. For this mirror component, we have two primary options. It is asking mirror plane, the plane about which you want to mirror this object. For that purpose, you need to select a plane. As you can see, we can't select a plane right now because it is already occupied by mirror components feature. For that purpose, go to the feature manager, feature tree, select the drop down, and select the respective plane. For our purpose, for our assembly, it is right plane. Select the right plane, and now it's asking for the components to mirror. We have this component to mirror. Select the component, and next, go to the next. It is already showing a preview of the component and how it will look after when you mirror it. Hit OK, and you have another copy of the component. As I already described earlier, that every feature in SolidWorks is non-destructive process. Like if you added any part of this component, this component, and the same feature will be applied to this feature. If I want to move this component, and it will move respectively to the other component. Movement will be applied to the respective other components. Let's select insert component and insert our third component. For third component, I want to select shop. Double click on shop and you will have your shop on your assembly. Select anywhere on your screen. Now, as you can see, we want this shop to be coincident with to be inserted into these holes. For that purpose, just select the circumference of the shop and the circumference of the hole. By selecting these two faces, you can see we have a pop-up of mates. For this operation, we want concentric. What's concentric? Concentric will combine two circles and make their circle center point coincident. Select coincident, and your part will fly to the respective position. Now, as you can see, all other components are fixed. Components are fully defined. Only this component is underdefined. This component can't move anywhere else, but it is free to move in this direction. To make this component fix on this bracket, we need to apply another mate. This mate is called width mate. What this width mate will do? For better visualization, go to the front plane. We want this pin to be equal distance from both sides. We want this pin to be equally distanced from the both sides. For that purpose, go to the isometric view. Drag this component outside of the assembly file. Now, select the respective component. For this operation, select the first component, hold down your control key, and select the second component. Rotate it, select third phase, and similarly select fourth phase. When you have selected four phase, SolidWorks automatically detect that you are trying to apply width mate. Just select the width mate, and SolidWorks will do the rest of the job for you. Go to the isometric view. Now we have created this assembly. This assembly is complete before one component only. As you can see, this pin is able to move, is able to rotate in along the axis. We want to insert another component. Just go to the insert components and select pulley. Here you have your pulley with your cursor. Now we want this pulley to be coincident with this job, this pin. Similarly, select the inner face and select the outer face. Select coincident relation. As you can see, our pulley is coincident with the pin, but we want similarly, just like with the pin, we want this pulley to be in center of these faces. For that purpose, we can select another feature that is called symmetrical. Select your part. You can see here is your part. When you look into the part, you can see different faces. You can also use width feature for this operation. Select first component, first phase, second phase, similarly rotate it, and select third phase and fourth phase. You can see we have width selection with your cursor. Select it, and we have our pulley fixed on the position by rotating. We have created our assembly. We just need to insert one component over here. Select the insert component and select bushes. Here are the bushes. To insert these bushes, bushing along this pin, we just select the outer face and select the outer face of this pin, of this pulley or the pin. Let's select the pulley, and we have coincident relation over here. Okay. Now we want this pulley. Now we want this face to be coincident with this face. Like we want this face to be in line with this face. Just select both faces, and we have suggestion of parallel, perpendicular, or coincident. For this operation we want coincident relation. Just select this, and we have Okay. We also need this bushing on the other side. We can go to the mirror component and select mirror components. But we already have, for the sake of simplicity of our feature manager, you can edit this feature. Just select the edit feature, and under the under the components to mirror, select the bushing. If you go next, you can see we have our bushing on the other side. This is our assembly completed. This was a part for tire of about furniture. I guess it's a part for furniture. There is also another component, like if you want to insert general components like bullets, bolts, nuts, bearings, or gears. You can use. You don't need to like draw components and make these components on your own. We have toolbox on provided with Solidworks. These toolbox include all the most commonly used features. Like if you want to select inches system, you can select inches. Currently, we are working in metric system and select NSI. You can see under this toolbox component, we have different categories like bearings, bolts, nuts, O-rings, power transmission. Under power transmission, you will find different shafts or different type of gears, retainer rings, and washers. For this purpose, we want only bolts and screws. Just double click bolt and screws, and you have different kind of bolts and screws. Let's go with simple hex head bolts. These are different kind of bolts you can install. To install or to insert a component, just drag a component, just hold a component and drag it into your feature tree, into your assembly. If you hover over your respective hole, it will create a suggestion for you. Now, as you can see, I want to insert a bolt onto this hole. It is already creating a suggestion for me. If I want to select this feature, this hole, it will go respectively. Let's select this hole and release your left mouse button. Now it is asking for different features, for different options, like what's the size of your bolt and what kind of other features you want. Let's say we want to select the size. You can see under size feature you have different options like M5, M6, and M10. This is the diameter of your bolt. If you go to the manufacturer and ask for a M12 bolt, you will find exact this bolt. After the size operation, we have length operation, length feature. You can see under this length operation, we have different length sizes. You can also select this operation from over here. Select your appropriate length, select your appropriate sizes, and you are good to go. If we select OK, it will create a bolt over here. Now it's asking if you want to insert other bolts. You can insert respectively. Let's say I want to insert a bolt over here, a bolt over here, and rotate your geometry, and a bolt over here. If you select a bolt and go to the feature manager and go under the mates in assembly, you can see it. Solidworks has already created some respective mates for us. For this operation, we need a coincident mate and a concentric mate. And this was our first example for today. You can simply save this file, go to the files, save as. It's asking if you want to rebuild your assembly. You can go without rebuilding or rebuild. We have already saved our file. Just double click, and it's asking if you want to replace it. Just hit yes. Now we have completed our first assembly. This assembly is fully working just the way it is meant to be. Minimize the assembly and we will move to the second part. Go to the new file, select assembly. For this operation, it's asking if you want to browse other components. Just hit browse, go to the directory. As you can see, the preview is available over here with the thumbnail, but it's a little small over here. Go to the right side and select Excel large icons. We have already provided this assembly file and parts file if you want to practice along the way. For this operation, just select your first part. I want to select this main bracket. Select this main bracket and double click. Now it's asking for the location where you want to position this assembly, this part. You can move this part, and also you can rotate this component. For this operation, I don't want to rotate it, and just hit OK. In the feature manager, you can see a cap over here. This cap means this part is only for educational purposes. If you want to use this for your commercial purposes, it's not allowed by the software. Okay, we have imported our first part. For the second component, go to the insert components, browse, and for the second components, I want to insert 𝐭𝐞𝐝𝐚. Double click, and here you have your file. Okay, I want this file, this part to be in concentric relation with this whole. For this operation, just select your first phase and hold your control key and select your second phase. Just like coincident relation. Oh, sorry, concentric relation. And your part will fly to the respective position. As you guys can guess, the first part is fixed and the other parts are floating. Our main aim is to to fully define every component. For this purpose, we have motion in the y-axis. To limit this y-axis motion, what we will do, we will select this phase, rotate it, and select this phase, and select coincident relation. As you can see, this part is ready to insert other components. This part is rotating, but it's not able to move in the y-axis. To view it from the other axis, from the other side, go to the view orientation and select this view selectors. For this purpose, I want to select this side. Okay, we are ready to insert another components. Hit insert components. Go to the browse switcher and select spider hinge. Double click on the component to insert it. Okay, for this operation, each component is colored in the respective manner, in the respective color. Like a blue color will go with the blue color, a red color will go with the red color. As you can see, blue color, I will select the first blue color and select the second blue color. It's asking for which kind of relation you want. We want a coincident relation. The part will fly to the respective position. Okay, now we have limited this part to be coincident with this male yaw. We want this circle to be coincident with this circle. Select both circles and select coincident relation. Here we have our assembly with 3 components. You can check, make sure your assembly is working as the way it's meant to be. Now select insert component to insert another part. Go to browse feature and select 𝐭𝐞𝐝𝐚. It's asking that the font that is being used by the owner is not available in your system. So select use the temporary replacement font. Here's your other component. Okay. As you can see, this part is also colored in the respective color. Select red color and select red color on this part. Select both faces and select coincident relation. Similarly, we want this face to be concentric with this hole. Select both holes and select concentric relation. As you can see, we want this face to be coincident with this side. We want this part to be in center of this part. For that purpose, select the last created coincident relation and hit edit feature. Okay. In the here you can see your both selected features, both selected faces. If you select first face, it will highlight which face it is. We want to delete this face. Go to the other side and select the other face. Hit OK. It's not working the way it's meant to be. So just select the last two features and hit delete. Now select first face and select the second face. Hit coincident. Now select inner face and this inner face and select coincident relation. Now you can see our assembly is working properly. Now we want to fix this plane, this face, this body to respective position. For that purpose, select this face and select this face and hit parallel relation. What it will do, it will make both faces parallel. Now, as you can see, our assembly is working properly. Now we can insert other components. Select the insert component, go to the browse feature, and select top handle. We have our component over here. Select, again, go to the insert components, go to the browse feature, and select handle. We want this handle to be concentric with this face. Just select both faces and select concentric relation. Now this body is fixed, but it's able to move up and down. To limit this operation, limit its movement, select this face and rotate it until you can see the bottom face. Select both faces and hit coincident relation. Now this part is fixed in the up and down in the vertical axis, and its position is also fixed. But this component currently is meant to move this part and this part. Like if we rotate top handle, it should rotate below assembly. To add that feature, go to the display style and hit hidden line visible. You can see in this part we have, for better visualization, select the component and select component preview window. What it will do, it will just temporarily open this component. What I'm trying to do is I want this face to be coincident with this face over here. For that purpose, you can go to the Select a component display style and hit uh, select this feature. Select this face and select this face over here and hit coincident relation. Exit preview, go to the isometric view. You can change the display style of this part to same as the other. Now, if I rotate top component, it will rotate the bottom components too. Now we want this component to be sitting on the top of the center. Parted operation, just select both faces and select concentric relation. This component is able to move up and down, but it's also not moving the other components. Parted operation, parted purpose, we have accidentally inserted a wrong file. So for that purpose, just hit this file and select suppress. This part was supposed to be sitting on the top of it. So select this inside face and select this face and hit coincident relation. Now we want these two faces to be concentric. Hit both faces and select concentric relation. We want this plane to be sitting on this face over here. Select both components and select coincident relation. As you can see, our geometry is overdefined right now. This means two mates are contradicting with each other. Those mates are following. Just select both mates and hit delete. For this operation, I want to suppress this operation temporarily. Select this face and select other face and hit concentric relation. Now we want this face to be coincident with this face. Select both faces and hit coincident relation. Now, as you can see, our assembly is defined and it's working the way it's meant to be. Now, all we need to do is to make this component coincident with this component. For this operation, I want to use another command. For this operation, just hold your Alt key and select your component. Now you can see our component is asking for another relation. Hold your middlemost button and rotate it. Now move it to the top face, and as you can see, it is already creating coincident relation. This is a quick way to add respective mates. It's asking if you want to add parallel mate and other mates. We want to add coincident relation and hit OK. Now you can see our geometry is ready and is working properly. By the way, this is our universal giant, which is used to transfer motion between two shafts that are not parallel to each other. You can also save this file. Go to Save Component, Save All, Rebuild and Save Components, and select your assembly name. Okay, we have successfully created two files. We are short on time, so let's be quick and let's visit advanced features over here. Let's minimize this feature. Go to the new file and go to the assembly. Go to browse feature. Go to your directory. For this operation, my directory is third folder. Select your first part. For this operation, I want to select part 3 sport. Just insert this feature, insert this part. Again, go to the insert components, go to the browse, and select your pulley. It's asking for some relation. Just hit OK, and as you can see, this component is fixed and this component is floating. I want this component to be concentric with this whole. Select both components and select concentric relation. I also want this component to be coincident with this component. Select both faces and select coincident relation. Go to the isometric view for better visualization. Again, go to the insert components, go to the browse, and select part 4 shop. We want this shop to be in four copies of this shop. Select this component, hold your control key, and make another copy. To make another copy, hold your key and drag your component. It will create 3 copies for you. We want this component to be concentric with this hole. Select both components, those faces, and select concentric relation. Again, select both components. For this operation, I want to use a quick command. Again, hold your Alt key and drag your component. As you can see, it is already creating a concentric relation for me. Again, select both faces and select concentric relation. As you can see, these shafts are able to move on x-axis. To limit this movement, go to the mates and hit multiple mates mode. It's asking for parent object. Our parent object is in this space. Select this space, and it's asking the child parts. Select the respective faces. It will move both faces to the respective position. Our current position is coincident, and it will make coincident relations. Select the other faces and hit OK. For better visualization, go to the isometric view. Close this command. Again, go to insert other components. Go to insert components. Go to browse and select your second part. I also want another copy of this component. Hold down your control key and add another component. Similarly, hold down your Alt key and move this component to the towards the job. It will add a concentric relation for you. We want this component. We want this component to be sitting on this face. Select both faces and select coincident relation. Similarly, select this face, hold your Alt key, and move this component. It will add concentric relation. Okay, we are a little short on time, and let's add this main. What we are trying to do, we want to control the movement rotation of this component by this component. For this operation, we want a pulley made. Go to the assembly features and select belt and chain. Now it's asking for 2 phases. For this operation, select first phase and select the second phase. It's already creating a preview of a belt for us. Just select OK, and it will do the job. Now, if you rotate first component, it will rotate the other component too. You can save this assembly to rebuild and save the document and save as assembly 3. That's all from our today's section.
Thank you so much, Ammad Ejaz. Here is an important announcement for you all. After workshops, there will be an assessment on the basis of which certificates will be given to those who will perform well. Now we'll be having a question answer session. If you have any query, you may raise your hand.
We have a query from our previous session, and a guy has asked, can you repeat the operation of merging operation? For this operation, go to the part file, start a new sketch, and draw a random geometry. Again, go to the front plane and start a new sketch. For this operation, let's go with a polygon. Go to the extrude feature, and here you can see we have another feature which is called merge results. What it will do, if we uncheck this operation, it will extrude the operation for you, but it will create another body for you. What are bodies in SolidWorks? It acts like two different components. Like if we select uncheck this merge operation and select OK. As you can see in your feature manager, we have two different bodies, and these faces are contradicting with each other. If we want to merge these operations, merge these bodies, you can go to the edit feature and simply select merge results. Now you can see we have only one body over here. There's another operation. There's another way to do this operation. Just go to the uncheck these merge results, and if you go to the right side and search commands and type in merge and type in combine. If you select this operation and it will start the operation, but if you go to the I command, it will show where this operation is lying. As you can see, here's the combine operation. It's asking for bodies to combine. There are other features for that. First feature is add. It will simply add both bodies. We can see we have only one body over here. Other features are subtract. What it will do, it will subtract the other body from the main body. You can hit show preview. This is the preview of part that will be created after that. You can also select common feature. What it will do, it will eliminate the other portions, but it will create a common portion for you. As you can see, here is a common feature. So that was the combine feature, common feature, and subtract feature. Another attendee has asked a question that how can we create a component? If you can see in your WhatsApp group, he has sent a picture. To create this feature, simply go to your favorite plane, make it normal. We are short on time, and I will do it as quickly as possible. Here you can see we have completed or created a simple sketch of your assembly that you requested. If you want to draw the exact file, you can visit me anytime and I will draw it for you. Another attendee has asked for the multiple mates command. For that operation, let's delete these features. For the multiple mates command, go to the mates and select multiple mate mode. Select the parent object. Let's say I want to mate these faces to this face. Select the parent face and select the other components. As long as you are selecting the respective faces, it will fly to the respective positions. Like the other face and also this face. If you look into the feature manager, we have created three coincident relation with one command only.
So here, no more questions. We have an important announcement. For today's session, we will be having our worthy speaker, Ahmed Abdullah, our lecture on additive manufacturing. He will be coming from Islamabad to have our session. In the end, I would like to extend my sincerest gratitude to the speaker and the audience for being here with us this morning and spending their precious time with us. Stay tuned for further modules. Have a blissful day. Allah Hafiz.